Hello, my name is Tracy Thompson, and for my chemistry and captivity project, I've decided to research why azurite is less common and less abundant than malachite. So I've done some extensive research, and from there, I've compiled this slideshow, and I can't wait to get into it. So All right, so we're going to go ahead and jump right into the presentation, and we're going to begin with azurite. So the chemical formula for azurite is promptly displayed below. I find it very interesting that it does occur worldwide, the same as malachite, but it's almost always found in conjunction with malachite, and we'll get into that later on in the presentation. But azurite is also a copper ore, which means that there is so much copper that is present in that rock, and it's very valuable material, so it's actually worth extracting. It's not like any other, material where it's not worth extracting the copper because you're only going to get a minuscule amount. It's much, much less stable than malachite, and that is due to its size. When an atom is bigger and it can fit a whole bunch of more stuff into it, it is way more unstable, and so therefore, um, it will always be less abundant than malachite, being that it will always try to simplify itself, and therefore being that malachite is the simplest form of azurite, it's its happy place, if you will, it will always try to invert back to malachite. Now if we move on. All right, so on the second slide for azurite, we're going to go ahead and jump into its formation. So it forms due to weathering Cu molecules or copper molecules in the right conditions. So what the right conditions can refer to is anywhere where precipitation can occur, in porous spaces. It can be breaks and cavities of rocks, but it has to be under the surface of the ground, and it has to be within the right environmental conditions, such as uh, if it's in a hydrothermal area, its humidity, just a whole bunch of factors, really. It also exhibits a monoclinic crystal system. So what that crystal system is it basically refers to a crystal that has vectors that are unequal lengths. So it forms a rectangular prism and it has a parallelogram as the base. And that's actually the case with azurite and malachite. They're both monoclinic, which is pretty cool. And then azurite is extremely soft and is very, very, very sensitive to the surrounding environmental conditions, which is also a key factor on why it is so difficult for collectors to keep their hands on in pristine condition, because even just reacting with the air can have a harmful effect on the azurite if you don't want it to turn to malachite, that is. It's best stored in a dark room that has temperature and humidity control, and it's extremely sensitive to heat as well, sun bleaching, all of that stuff. So you want to make sure that it keeps away from all of that. It's a compound carbonate, the same with malachite as well, and again, it's very unstable. So if we move to All right, so now we're going to go ahead and jump straight into the malachite portion of this presentation. So the chemical formula of malachite is promptly displayed under the title. This is the formula that I was referring to earlier, that you wanted to make sure to really note the similarities between this formula and then the one of azurite. So malachite is also found worldwide, and it is most commonly found in the banded form, but it's also extremely commonly found in the fibrous form as well. It depends on where you get it from. So it's most commonly found in fibrous form. Um, if it forms in deep cracks where precipitation takes place. However, the distinctive banding form actually is partially created by the subtle changes in the oxidation states of surrounding pore waters, which is very interesting. It's also a weathering or secondary or even pseudomorph is another word for it, product, which means that it's actually the product of azurite morphing into um, malachite as a chemical change goes on inside. It's also a compound carbonate and it serves as an indicator of copper, meaning that if you find a cluster of malachite or actually azurite, then it is a very good indicator that if you keep digging in that same vicinity, then you are bound to find copper as well in great, great abundance, which is pretty cool. Um, these were also found, um, I'm sorry, I lost my train of thought. Malachite is also present in every oxidized Cu deposit, which is pretty cool. And then it's extremely much more abundant than azurite, being that azurite does actually turn into malachite. And if we move on to the next slide. All right, so now we're going to dive right into part two of the malachite and how it forms. So it forms when dissolved copper is transported via water until it reaches its new environment where the conditions are just right. So normally that includes like the evaporation, the new temperature it's experiencing, and the water chemistry, for examples. And then when malachite does form, it's most likely to form two different types of formations, the stalagmitic and the botryoidal. My apologies if I completely butchered those pronunciations. However, the botryoidal is going to be the top picture, and then the stalagmitic one is going to be the bottom right, and on this slide particularly. So the crystals form in fibrous articular tufts as well, and that's going to be when the precipitation is just right and it's deep, deep, deep down between rocks, and that's going to be the bottom left-hand picture right there too. We have already discussed the distinctive banding, some fun facts about ancient Romans and what they believed. They really loved using everything for protection against like evil spirits and such, and the Egyptians actually melted malachite in order to get copper, so that's interesting. And then if we move on to the last. All right, and then that brings us to our next slide. I did make an executive decision not to go over the previous slide with a voiceover purely for time's sake. I didn't feel like it was extremely that pertinent, just really cool information. So the crystal that results from azurite chemically changing its composition to that of malachite is an azure malachite. It's actually a combination of both malachite and azurite as it begins a slow process of inversion to its new form. Transitions from azurite to malachite happen due to the correct environmental factors, and that inversion chemical reaction formula is actually listed right below. And if we go to the next slide. All right, and now we're going to go ahead and take a look at the mass percentage of copper in both crystals. So promptly displayed on the screen are the formulas for azurite and malachite, only differing in one copper atom and one carbonate polyatomic ion. So the purpose of finding the mass percentage is to determine the concentration of an atom or an element in an entire compound. So what we did is we took the number of copper atoms in the entire compound, multiplied that by the molar mass of copper found on the periodic table and divided it by the entire molecular weight of the compound and multiply that by 100. So what we found is azurite actually had way more copper by mass with 55.31%, which means that if you were to mine for copper, you would want to mine azurite instead of malachite.